This law states that the velocity of center of mass of a system cannot be changed until some external force is applied to the system. So to understand it, let's take an example. Suppose there is a block A, which is our system, and the velocity of the center of mass of block A is VA. So the block A is moving with velocity VA. So according to Newton's first law, to change this velocity there must be some external force which is acting on block A. This is our F external. So if F external is 0, the block A will continue to move with velocity VA. Similarly, suppose that the block A is at rest, which means that the velocity of its center of mass, that is VA, is 0. So the block A will continue to be at rest unless we exert some external force on it. So if F external is 0, block A will continue to be at rest. To visualize Newton's first law mathematically, let's get back to the definition of F external. We have seen that F external is equal to sigma m into dvc by dt, where Vc is the velocity of center of mass, now let's see what happens when there is no external force, that is F external is 0. So in this case, sigma m into dvc by dt will be equal to 0, or dvc by dt will be equal to 0, which means that Vc is constant. So in the absence of an external force, the velocity of center of mass is constant, which is the same thing as stated in Newton's first law. Now we will see how law of conservation of linear momentum is consistent with the Newton's second law. This law states that the linear momentum of a system remains conserved until some external force is applied to the system. So we know that the linear momentum of a system, that is P system, is equal to sigma m into Vc, where sigma m is the total mass of the system and Vc is velocity of its center of mass. Now according to Newton's second law, F external is equal to sigma m into dvc by dt. So if there is no external force, that is F external is 0, we have sigma m into dvc by dt is equal to 0, or dvc by dt is equal to 0, which means that Vc is constant, that is the velocity of center of mass is constant. So if we are dealing with constant mass system, we have total mass of system sigma m, which is constant, and we just saw that if there is no external force, Vc is also constant. So now we can say that in the absence of any external force, the linear momentum of a system, P system, is constant. Now let's see what is a normal reaction. Whenever two bodies establish contact, at the point of contact they press against each other with equal amount of force. This force is called normal reaction, and the direction of this force is always perpendicular to the common tangent at the point of contact. To understand it, let's take an example. Suppose we have two balls, ball A, and we have another ball, ball B, which is touching ball A at some point. Let's say this point is B, which is our point of contact. So since ball A and ball B are touching each other, they will exert a normal force on each other. So on ball A we have a normal force N1. This is being exerted by ball B, and similarly on ball B we have a normal force N2 which is being exerted by ball A. So these two forces are equal and opposite to each other. So we have N1 is equal to minus N2, which also means that the magnitude of these two forces are equal. Now the direction of this normal force is perpendicular to the common tangent. So if ball A and ball B touches each other at point P, this is the common tangent at point P. So the normal force acting on ball A and ball B will be perpendicular to this common tangent. This is N2 and this is N1. So now we are going to start a new chapter, which is friction. So first let's give a small introduction about friction. Friction is a force which opposes the relative motion or tendency of relative motion between two surfaces in contact. So suppose we have two blocks, block A and block B. This is block A and this is block B, and both these blocks are in contact. Now suppose a force F is applied to block A in the right hand direction. So block A will try to move in the right hand direction. Now the motion of block A with respect to block B is in the right hand direction. So since block A and block B are in contact, the friction force will be applied on block A, and the direction of friction force will be such that it opposes the relative motion, that is the motion of block A relative to the contact, which is block B. So since block A is moving in the right hand direction, the friction force on block A will be in the left hand direction. So this is our friction force. Let's denote it by Fr. So the direction of friction force is always such that it opposes the direction of relative motion. Now the friction force is applied on both the surfaces in contact with equal magnitude and opposite direction. So if we take the same example of two blocks, so we have seen that we have two blocks, block A and block B, and a force F was applied on block A so that the block A moves in the right hand direction. So as we have seen, the direction of friction force on block A is in the left hand direction. This is friction force Fr. This was because the motion of block A with respect to block B was in the right hand direction, and the friction force will be in such a direction that it opposes the relative motion. Now since block B is also in contact with block A, a friction force of same magnitude but opposite direction will act on block B. So the force acting on block B would be again Fr, and this will be in the right hand direction. So as we have seen that the direction of friction force is such that it opposes the relative motion, so we can say that friction force tries to stop relative motion between two surfaces in contact. Now if the two surfaces in contact are at rest relative to each other, the friction force tries to maintain this relative rest. Now let's find out what is the value of friction force. Friction force between two surfaces can reach a maximum value, which is called limiting friction, and this value depends on the nature of the pair of surfaces, and it is proportional to the force of normal reaction between the two